Hello and welcome to another little software development tutorial on this channel. In this video, I'll show you how to use treesitter to parse source code. As an example, I show you how to create a Python program to parse Kotlin code. I show you how to install treesitter and the grammar for Kotlin, how to use them to create an abstract syntax tree from a string of source code, and how to use treesitter queries to extract certain parts from that tree. As usual, you'll find a link to the code I show in this video in the description below. You can use it as boilerplate for your own parsers. But first, what is treesitter? Treesitter itself is not a parser, but rather a parser generator, which is mostly used to generate parsers for different programming languages. To generate those, it needs the grammars of those languages. Thankfully, grammars are already available and well maintained for most programming languages you can think of. And since a few months, we also get official Python wheels for them. So it's easy to use treesitter in Python without the need to generate and compile the parsers yourself. Natively, treesitter is mostly written in C, but language bindings exist aside from Python also for many other popular programming languages. Treesitter is also widely used in different code editors like NeoVim or Atom, to name just a few. And one of the reasons for that is treesitter's queries, which I'd say is one of its biggest strengths. With other parsers I had to either use a wizard pattern or listeners to access different parts of a tree. Treesitter queries make this task a lot simpler, as I'll show you in this video. So let's have a look and see how it works. To understand how treesitter queries work, a good place to start is the official documentation, which I'll link in the description. So take your time, read through it, maybe even twice. So I had to do it twice. You'll really learn about all the different possibilities of creating queries, but from my experience, it's much better to directly play around with an example and by this really understand how to construct the queries. And then with the documentation, you can go from there to more complex queries. To test queries, treesitter also provides a playground, which is great to understand how to create queries. You can also use it to create very specific queries for your programs, which is also what we're going to do here now for the program I want to write, so the Kotlin parser. So what I've done here, I've filled in some very simple test class. It doesn't make much sense what I have here. For example, down this part, I have a public function calling a protected function, calling a private function. Don't think too much about the code itself. I just created it in a way to produce an interesting source tree, which we can then explore with queries. And if you activate this checkbox, you get this query field, and you can use this one here now to create queries. And yeah, if you click here, you'll always see in the tree directly the proper location. So here we're currently clicked on a class declaration. And if we click here, that's the identifier of the class or the class name. Let's just click down here on a function. You see here we have a function declaration, which consists again of an identifier, some function parameters. We have a user type, in this case the return type, and we have a body. So this is how the tree is constructed, and you can go all the way down to its leaves. So you see here the expressions, left side, right side, if you're interested in that. So for our example, let's say we're interested in getting the classes from a source file and then exploring those classes. For example, extracting all the properties of the class, all the methods. I think this is a very simple practical example, something you might want to do for your parsers. So let's start now. First, very simple. We just want to write a query that gives us the class declaration. And this is very simple. Each of those nodes here, for example, the block comment node, the statement node, the class declaration node, you can query it by using brackets and then naming the node you're after. For example, I've now said, okay, I'm interested in the class declaration. And if there were more classes, this would give me or select all class declarations. You might now ask, okay, nothing's selected up here. Why don't we see it? This brings us to the second part, those queries. You need to capture the results somehow. You do this by specifying here a capture group. And we just call this group classes. And now you see highlighted up here with the same color we have here in this capture group, the class declaration. Now, this is very simple, but we can get more detailed. Let's say, okay, now we want to get all function declarations in a class. So for example, down here we saw there's this function declaration. The function declaration resides inside of the class declaration. So there are some steps in between which we can now use here. First of all, we make this a multi-line expression. This is representing the tree much better and makes it easier to construct those queries, in my opinion. So inside of a class declaration, if we look here, what we have the class body. So let's just ident it and go class underscore body. Now this is the class body. We could also capture it if we want. So let's just do this, class bodies. And I always use plural here because it would capture all the class bodies in the file. And now you see here the classes, the orange color and the body blue color. But we don't need to capture this one because we're interested in the function declarations. So let's again go one step deeper and see, okay, now here we have a companion object. We're not interested in that. Property declarations. And down here we have a function declaration. So let's just use function declaration, specifying function node. And again, we capture it as methods. And now we see, if we scroll down here, highlighted blue, like the capture group, we have all the functions in this class selected. So this is already pretty nice. And you can also see from here, we could go even deeper. For example, we can go into the function body, we can look at turn expressions and so on. Now, one important thing which is helpful here, let's just imagine we have two classes. I'll just copy and paste this class for simplicity. So let's just put it down here and give it another name. Let's call this second car. Or another car class, another car. So you see both classes are now highlighted. So here we have the orange class and up this one too. What if you were just interested in one of those in the class with the identifier car? And you can do that. And let me show you how. There are special expressions about which you can read in the documentation. So those expressions use so-called predicates, and you have here equality, not equal, and any not equal. And you can use those like that here to compare, for example, an identifier and just select those in your capture group. But yeah, this is maybe a bit abstract here. So let's just do a practical example. In the playground, what we want to do, we want to just capture one of those classes, the car class. So we're interested also in the identifier of the class, and we capture it as class names. And we can now use this capture group here and add a predicate, equality predicate. We're interested to use the class names, and we just want the car class. So now here you see the car class still selected, but if we scroll down, another car class is no longer selected, neither are the functions. So this way here, we already made our query more specific, and this is very helpful. And yeah, from this base here, from this foundation, you can go and create much more complicated queries. And you can also use here the other predicates. You can even use regular expressions. There's a lot more, but I think I'm going to leave it at that. And we're now going to move to Python, and I show you how to use queries in a Python program. So here we're in Python, and as usual for my open source projects, this one's included on my GitHub. I'll link to it in the description. It also includes a dev container, which already contains all the tools for Python development. So we have formatting, we have linting, everything you might need. If you need more, well, go ahead, just extend the Docker file or use this one as base and build on top of it. If you're not familiar with dev containers yet, I have videos about those. So I'm going to link those also in the description. So watch those. With those, everything will work out of the box. So I'm already in the dev container here, and I provided here a script. So the first thing you need to do, you call the init script. And what this will do, it will just install the dependencies, which I have already done. And you see here in the requirements, you see tree sitter and tree sitter Kotlin. So those are the two packages which we need to create parsers for, in this case, Kotlin in Python. You could also just use pip to install them, but since I already provide the requirements here, you can use my project as boilerplate if you want, and you're ready to go. I also have a TOML file which defines how to build a package, so you can use this as dependency in other projects. I have tests, and this is what we use now to explore how the parsing works in Python. Let's have a look here at the Kotlin parse test. So here I have the same test class which we just had in the playground, and down here for now I just have a very simple test. So test Kotlin parse, which just uses this function which I'm going to show you in a second, get Kotlin class. It passes in the code and it tells which class we're interested in. So this is exactly what we just did with the queries, and I now show you how to basically take the knowledge from the playground and apply it in Python code. And we also extend it at additional tests. But what I want to mention also here, if you're in Visual Studio Code, I already included a debug configuration with this project. So let's just click here. You can just click on Run Debugger. So it will run the test, but it allows you to step through it. So I can step into this parse Kotlin class. What it does, and that's the important thing, first we create a parser. So from TreeSitter, we include this parser class here, and down here I have this as a global object. We construct a parser with a language, so that's the grammar we want to use. And yeah, let me just show you the language, how it's defined. So I've put it here into a little hierarchy because this parser TS, we could have other parsers. So for now we have Kotlin, and here is this language pi. In it, we include TreeSitter language. And down here from the TreeSitter Kotlin package, we include everything and call it TS Kotlin. So this is basically the grammar which we want to use to create or generate our specific parser. And from it, we create a language from this grammar. So this is the code you need, and you can also find it in the official documentation on the TreeSitter Python GitHub. And yeah, now that we have this Kotlin language, we can use it. So let's go back to where we're currently at with our debugger. So here you see we create a parser by passing in this Kotlin language into this parser class, and with this parser, we can then parse our source code. There's one thing, so we can't just pass a string. So we first need to encode the string because this parse function accepts bytes. And yeah, that's all we need. If we step over this and look at the tree, let's just go here, look at our tree object. You see here we have now a root node. And if we open this, you see this root node has a few children. Let's go down and find those. So we have some named children. Let's open those. So here we have a block comment. Then we have a statement. Let's open this. This again has a child. Let's go down to the named children. And here we have our class declaration. And then we can open it and again go down to the children and so on and so forth. And this is exactly here what we have now, the tree which we saw on the playground. But yeah, it would be very cumbersome if we had to parse it like this. You could do this. So you could walk the tree like that, and TreeSitter provides tooling for that. But as I said, we want to use queries. So let's step into this Kotlin class here. So that's just the wrapper class I created. And in the constructor, we pass in the tree and the class name. So let's step into it and see what the init method does here. We create a query, and that's essential. This is how you use queries. So you have your Kotlin language, the same one we use to create the parser. And this Kotlin language has a function or a method called query. And you pass a class query, which is just a string, a query string, to this function. And let me now show you how this looks. So I have another file here just to keep everything organized. I have queries, and this is our class query. And you see, this is exactly what we've just built. So we are interested in class declaration, and not just any class declaration. We want to capture the identifier under class names. And then here we use this predicate to compare it to class name. This class name, if we look again here, we provide here via this format. So we format this string. And in our case, if we pass car here, then the query would just be the exact same we had in our playground now. So here in this line, you're actually doing the query. So you want to capture different capture groups, define the query. And then what I just check, if we don't have a class capture group, so we didn't find any classes, then we just raise an exception. Otherwise, I'll just save this class node. So what's returned here, those captures, this is usually a dictionary of those named groups which you define in the query, and then in each group you have an array. In our case, since we have this equality predicate, we're just interested in the first result here, which will be our car class. And this here returns a node. So if we go back here to our debugger, if we go up here to this line here, this class declaration, this 0 here, this is what we're capturing, and this is of type node. And the great thing of doing it like this now is, now we have not the root node anymore. So up here, the root node, which contains everything. We've now used the query to get just a part from the tree. And what we can do now, since it's again a node, we can run further queries on this specific node. So down here I already defined some functions which are still empty. So this is what we're going to do now. We want to, for example, get all the constructors, all the properties, all the methods from the class. And after we did the init, we have access to the class node. And when we use those functions here with queries, just on that node, we'll just get the functions from this specific class. Versus if we were to run those queries on the root node, we would get constructors, properties, and methods on any class in this complete source code. So this way is how you can refine your queries. So you don't need to make very specific queries, single queries that drill very deep into your tree and are very specific. If you're using a language like Python, you can first extract the sum block from the tree, some node, and then run queries on this. And you get other nodes. And then you could get even more specific. So that's really the power of how to use queries in a language like Python. And now I have talked enough about the theory. Let's just put it into practice. But first, let's finish this test here. And the test just passed because no exception was thrown. Let's also quickly just go to our test and just change here the identifier car2. So now we shouldn't find a class. So let's run the test again, and you can just, and if you don't want to run it via the debug, you can just use scripts, run test. And now you see there's no class in the source tree. So that's nice. So far, our program, our testing, everything works, and we can build from that. And I'm realizing this video is dragging on quite a bit, so let's just focus on one of those methods to keep it short. I'll leave it up to you to implement the rest or whatever you need. So let's do the get methods because we already kind of did the query for that. So let's go to the queries and add our methods query. So this is basically the query we've constructed before, just without this part here. Because as I just told you, we're not running this query on the root node anymore. We're running it directly on the class declaration node. So we can leave the query like that, and we'll just get the function declarations, the methods from the node from the class we pass in. Next, since here we don't have any variables in the string, we can directly also create our query. Now we can directly use this one here in our class. So let's import it. And down here, let's remove this code. We can now just do method captures equals to methods query captures. And now we no longer use here the tree root node. Instead, we're going to use self class node. Now here it's complaining because we need to return something, and we also need to satisfy mypy. So let's just say we will just return a list of strings, which will contain the complete method declarations. So just to keep it simple, as I said, you could further drill into the methods and extract parts of this. So up here, let's just define our list. Methods will first be an empty list, and let's just return it to satisfy mypy here. And now we want to extract the actual method strings and populate this list here. So first, if we have methods in our method captures, because it's possible that the class doesn't have any methods at all, and we wouldn't have a capture group. So we need to check this. If that's the case, then we want to loop through those for method node in method captures. And as we've seen up here, this is usually a list, so we can loop through it. And yeah, we'll get access to all the method nodes. And now each node usually comes with a text function. This will give us access to the complete bytes of the block that's defined by the node. And same as we had to encode our queries into UTF-8, we need to decode this. And yeah, we can directly append it to methods. So here mypy complains, because this could possibly return a none if we weren't careful here. In this case, I'm just gonna ignore the warning, because I know that for the nodes we're stepping through, there will be this text block and we can decode it. So yeah, we don't need to bother with the types for now. And yeah, that's the function. I also have up here this visibility. Yeah, as I said, for simplicity now, I'm not going to use it. If you want, feel free to refine the query and, for example, have a selection of just the public, private, or protected methods. But yeah, for sake of simplicity here, we're just going to leave it at that. And now it's time to write a test. So let's go down to our parse test. Just going to extend this test here. So we now have the Kotlin class and we can call the get methods. This will give us a list of methods, and now we can run some asserts. So for our case, let's just have a look. How many methods do we expect here? We have this drive function, 1, 2, 3, 4. So we are expecting 4 methods here. So this is an assert we can just write. Assert ling methods is equal to 4. And now let's just run the test. And it passed. So if we were to say we want 5 methods, it would fail. Next, what we can do to refine the test, we can also check what's the content. So assert methods, let's see, method 0. We want to check that it actually contains this string here. Let's just check this. So this worked. Well, let's just say we have a mistake here. So it's always good to also let your tests fail. Okay, this works. So let's now check the others. I just copy this. Let's run the test. And what happened here, you see that for some reason, method number 2 here is not the protected one, it's actually the private one. So what's wrong here? Something wrong with our ordering. Let's run it again. And now it passed. So something strange happens here. And that's actually an important thing to know. So those capture groups, it seems they're not capturing in a consistent order. So the order of the array here, of those captures, can vary. So if you want to be sure to have them in right order, I already have here a little helper, sort nodes list, called sort nodes list. And we should actually call it to make sure that the ordering is correct. So let's go to our Kotlin class. So just instead of just directly going here through the nodes, what we'll first do, we'll sort the nodes. So sorted method nodes equals to sort nodes list. Going to pass in this node list and then use here the sorted methods. No longer need that here. And now let's run the test again. Passes. And now it will always pass. The reason is each node has a start point, which you can access here, the start point row. And here I can just create a simple lambda where I make sure that the ordering for those start points is in ascending order. And yeah, we don't have some mix up between the nodes. This is a very simple sorting you can do here in Python based on the information you get from the nodes. So you're not just getting the text, you also get, in this case here, the start point. You get also the end point, stuff like that. So there's a lot of information in those nodes which you can use. And yeah, now you've seen we made sure that we can initialize our Kotlin class here. We can extract methods, and yeah, from here, we could extend it, also write functions for the properties. And as I said, we could extend this get methods class to say, okay, just the public methods is what we're interested in, and yeah, go from here. But what I wanted to show you here is just the foundation, provide the boilerplate, and can extend it to your liking from here, and also include other classes, so other languages. Now we have Kotlin, you could use C++, Java, JavaScript, whatever you find in the official Kotlin grammars. And if you're really into it, you could even create your own grammar for your own language. But yeah, that's beyond this tutorial for sure. Okay, so yeah, that's it. That's the fundamentals of treesitter and how you can use it in Python. I hope you liked it. If so, make sure to leave a thumbs up, and yeah, see you in the next video, whatever this will be.